Brought to you by BS Productions.
Bro and sis, what were you thinking? Cartesian graphs.
One of the first things you get to face in algebra are the two knowing how to understand letters x and y.
But where do these two figures come from? Why do you need them? The best answer to that question is in their history.
René Descartes, a famous philosopher and mathematician of the 17th century, is known for many different works, but one of his most famous ones was the Cartesian graph.
This graph worked with two variables, x, which marks the horizontal distance, and y, which marks the vertical distance away from the center of the graph. When these two values join, they make a point.
The graph was divided into four sections. In section 1, both the x and the y values are positive. In section 2, the x is positive but the y is negative. In section 3, the x and the y are both negative, and in section 4, the x is negative while the y is positive.
This is an example of a two-dimensional graph because it has two variables. Graphs have one dimension, two dimension, three dimension, or more.
The Cartesian graph was a very important discovery because it connected geometry and algebra, making way for new ideas and theories. For example, if somebody wanted to draw a straight line, they could graph the equation y equals x. This means that for every x value, the y value would be the same. That makes the y variable dependent on the x variable because the value of y is determined by or depends on whatever x is.
So if x is 1, y is also 1. If x is 3, y is 3. X is 5.5, y is 5.5. And if x is negative 6, then y will also be negative 6.
All these points can be connected into one straight line, y equals x.
But lines aren't the only thing that can be drawn. The equation y equals x squared makes a u, and the equation y squared plus x squared equals 4 makes graphs a circle.
This connection between geometry and algebra allowed many mathematicians to think of new theories and make new rules that apply to the mathematical world and physical world around us.
Blah, blah, blah. Great for them. But how does that help us?
Well, we use graphs a lot in our day-to-day lives. For example, if I told you that I was running from our house to my soccer practice, which is about 1,500 meters away, and I took 8 minutes to get there, while my friend Jacob ran 1,000 meters to practice and it took him 5 minutes, it wouldn't be very easy to tell which one of us was faster, right?
Well, not like that, but how could a Cartesian graph help us?
Let's draw one. For x, we'll put the time that passed. For y, we'll put the distance. We'll only use the first quadrant because both the time and distance cannot be negative numbers. Now, first let's see how fast I ran.
Well, at first, when no time passed, you didn't move at all, so you can put a point there. Then, after 8 minutes, you ran 1,500 meters, so we can put a point there.
Yes, and if we connect these 2 points, we have a line that represents how much distance I ran over how much time has passed, or in other words, my speed. The steeper it is, the faster I go.
Now, Jacob has only started at no distance and no time, or 0, 0. He took only 5 minutes, but he only ran for 1,000 meters.
Wimp.
If we connected these 2 points, however, his line looks steeper than yours. What did you say that means again?
How about we go to the next example, don't you think?
Oh, that's right. His line is steeper because he ran faster than you.
Moving on.
Okay, let's say I take shots at my local gym. Every day, I take 30 shots from the free throw line. My friend Paige, who started 5 days before me, also goes to the gym and takes 20 shots from the free throw line. I want to catch up to her, so I'm wondering, how many days pass until I have to take the same amount of shots as her? Let's graph and see.
Now, on the x-axis, we will put the number of days that pass. On the y-axis, we will put the number of shots taken.
On day 0, we both had 0 shots, but on the first day, Paige took 20 shots. On the second, she had 40, on the third, she had 60, on the fourth, she had 80, and on the fifth, she had 100 shots.
Now, that's enough points to draw a line. Notice that we can go past the point we're doing on the 5th day. This means that if your friend keeps on going at this rate, on day 6 you will have taken 120 shots.
Yes. Now, I only started taking shots on day 5. On that day, I took 30 shots. The next day, I took another 30 shots, or 60 shots overall. On the day 7, I go to 90 shots. These are enough points to draw my line. Again, I can go past day 7 because I know that I will keep going at a rate of 30 shots per day.
We can see that the lines meet at the point 15,300.
So that means that on day 15, my friend and I would have taken the same amount of shots, 300. So I will have to wait 10 days until I can start to catch up to my friend.
As you can see, Descartes' invention is very useful beyond just abstract problems in your math book. The 2 examples we've shown you don't even begin to describe all the calculations you can use Cartesian graphs for. In fact, complex areas of math, such as calculus, are all based off of this x and y grid.
Just like Descartes understood, math is ready to be discovered in new theories and ideas. Who knows, maybe you might find the basis of the next chapter in math. All you have to do is keep an open mind and look around you, because math is everywhere.